Hey everyone, and welcome. Getting geared up for your GCSE Chemistry exam? Well, you're in the right place. We're about to nail down a super important topic, how we use our planet's resources. We're going to power through everything you need to know for AQA topic 4.10.1, from fossil fuels all the way to some futuristic ways of mining. Ready? Let's get into it.
So, here's the game plan. We'll kick things off with the big picture, the difference between resources that run out and those that don't. That leads us perfectly into the huge idea of sustainable development. Then, we're going to zoom right in on our most precious resource, water. We'll look at how we make it safe to drink and what happens to it after we've used it. And to finish, we've got some really clever chemistry for all you higher-tier students on new ways to get metals.
All right, let's jump right in with the absolute basics. Everything we use, from our phones to our food, comes from the Earth. And this is a big but. Not all of these resources are the same. Getting your head around the difference between finite and renewable is the foundation for this entire topic.
And this slide pretty much says it all. Over on the left, we've got our finite resources. The best way to think about these is that there's a limited supply. Once they're used up, they are gone for good. Things like fossil fuels and metals took millions of years to form, so we can't just whip up a new batch. Then on the right, you've got renewable resources. Think timber. We can plant a new tree and it'll grow back within our lifetime. And that's the real key here, the time scale. Can it be replaced in a human lifetime? If yes, it's renewable.
So, if we know that we're going to run out of some stuff eventually, it forces us to ask a really important question, doesn't it? How do we keep things going without using everything up? Well, that brings us to our next key idea, sustainable development. And trust me, this is a phrase you are definitely going to want to remember for your exam.
Okay, so that's the official definition, and yeah, it's one you should probably learn. But what does it actually mean in plain English? Well, it's basically about not being selfish. It's about finding a way for us to have everything we need today without messing things up for our kids and grandkids in the future. It's all about finding that perfect balance.
Right. Let's apply this thinking to the most important resource of all, water. I mean, it's everywhere, but you can't just go and drink straight from a river. So what magical chemical process happens to get it from a murky reservoir to the clean water that comes out of your tap? Now, before we get into the how, we need to nail down the what. And listen up, because this is a classic exam trap. The water from your tap is what we call potable. That just means it's safe to drink, but it is not pure water. See, in chemistry, pure water is only H2O molecules and nothing else. Your tap water actually has lots of other harmless things dissolved in it, like minerals. So remember, potable is safe, but it doesn't mean pure. So here in the UK, we're pretty lucky to have lots of rivers and reservoirs, so the process is actually quite straightforward. It's basically a three-step cleanup job. First, you find a good source of fresh water. Step 2 is filtration, where you pass it through filter beds to get rid of all the obvious bits, like leaves and grit. And finally, the most important step, sterilization. This is where we kill off any harmful microbes using things like chlorine or UV light.
But what happens if you live somewhere hot and dry, without loads of fresh water? Well, you've got the whole ocean. The process of getting the salt out of seawater is called desalination. The problem is, it takes a huge amount of energy. I mean, can you imagine how much electricity it would take to boil enough seawater for an entire city? It's possible, but it is incredibly expensive.
Okay, so we've got clean water coming into our homes. But what about the water that leaves? Every time you have a shower, flush the toilet, or pull the plug on the sink, all that wastewater has to go somewhere, and we can't just pump it straight back into the rivers, right? It needs some serious treatment first.
Yeah, treating sewage is a bit more involved. First up is screening, which is exactly what it sounds like. They use massive screens to catch any large objects. Next is sedimentation. They let everything settle, and the solid waste sinks to the bottom. We call this sewage sludge. The liquid left on top is called effluent. Now these two get treated separately. The sludge is broken down by bacteria that don't need oxygen. That's anaerobic digestion. And the effluent is cleaned by different bacteria that do need oxygen. That's aerobic treatment.
Okay, quick brain teaser for you. Thinking about what we've just covered, out of fresh water, salt water, and wastewater, which one do you think is the easiest and cheapest to turn into drinking water? Hit pause for a second and think about the number of steps and the energy needed for each one.
Right, we're now moving into higher tier only content. So if you're doing the foundation paper, you can chill out for the next few minutes. For the rest of you, we're going to look at some really clever chemistry for getting metals out of what we call low-grade ores. That's basically rock that only has tiny amounts of valuable metal in it.
Just to be super clear, this next bit on phytomining and bioleaching is just for you higher tier folks.
Okay, so the first of these clever methods is called phytomining. The name itself gives you a massive clue. Phyto comes from the Greek word for plant. So yeah, we are literally talking about mining with plants. It's an amazing way to get metals like copper out of the ground without digging huge, damaging mines.
So how on earth does it work? Well, it's this really neat four-step process. First, you grow specific types of plants on soil that has the low-grade ore in it. As these plants grow, they actually absorb the metal compounds through their roots and store them. So the plants do the hard work of concentrating the metal for us. Then you just harvest the plants, burn them, and the ash you're left with is packed full of the metal compound, ready to be extracted. The second method you need to know about is bioleaching. Again, that little word bio tells you we're using life, but this time it's bacteria. Basically, certain bacteria can break down the ore and produce a solution called a leachate, which is now rich with all the metal compounds we want. Once you've got that solution, you can get the pure copper out using either displacement with scrap iron or by using electrolysis.
And that brings us to the end of our rapid revision session. I think the big takeaway here is that chemistry is absolutely central to solving some of our planet's biggest resource problems. From making sure we have safe water to drink to literally mining with plants, it's all chemistry. It really makes you think, doesn't it? As our resources get more and more scarce, it's going to be chemists finding these clever, sustainable ways to make the most of what we've got. Thanks for joining me, and good luck with your revision.